In this lesson we're going to continue to look at the motor effect that we looked at in the previous lesson, and this time what we're going to do is we're going to introduce a simple rule to tell us in which direction the force acts on a current carrying conductor in the presence of a magnetic field. You remember in the last lesson we looked at this from the combined effects of the magnetic fields produced between the permanent magnets and the magnetic field produced by the current that flows in this conductor. That helps to explain to us what's going on, but it's quite a complicated way of working out which way the conductor will move. So the left-hand rule really helps us to do that. Let's have a look at this rule. So you hold up your left hand in this position, and the motion of the conductor, that's the direction that the force acts on the conductor. Alright, let's just put that in there. That's the force. Direction of the force is the direction that your thumb is pointing. Okay, and the magnetic field is the first finger, and the direction of the current, that's the conventional direction of the current, is the second finger, is your second finger. So let's just remove the word finger. We know those are fingers. And so just to help us, we've got thumb, M, for motion. We've got field, F, for field. And then the current, that's the C in second, right, to help us remember. Okay, so what you've got to do then is you've got to kind of hold your hand in that position and turn it and twist it around until you get the fields and the currents in the right direction. Okay, so let's just have a look at an example. Alright, supposing we've got the current coming in this way. Okay, it's coming through here, and then in the direction that we're interested in, there it moves along this free moving conductor which can roll along these parallel supporting rods and then out this way. Okay, so there's the direction of our current going this way, and let's just say that we've got north, north, south, south. So our magnets are going north, south, north, south. So the direction of the magnetic field will be from north to south. So looking at the side view, what we've got is at the moment the direction of the current is going into the screen. So we draw a cross there for into the screen. The direction of the magnetic field will be from north to south. Okay, so our field direction is like that, or I'll write B for magnetic field. Okay, so the question is, what is the direction that the force acts? So first let's look at the magnetic field. Okay, that's my first finger. So you've got to hold up your left hand, point your first finger upwards. What's the direction of the current? Well, the current is going into the page, so you've got to twist your hand around so that your second finger is pointing into the screen. What direction is your thumb pointing now? You'll notice this pointing to the right. So the direction of the force that acts on this free moving conductor is to the right, so that's the direction in which the conductor moves. Right then, let's just change the situation a little bit. Let's swap the magnet poles around. So we've got north, north, south, south, and we'll keep the direction of the current the same. So now this is the direction of the magnetic field, going again from north to south. So you take your first finger, you point that downwards. This is where it starts to get a little bit awkward, and then your second finger is still pointing into the screen because that's the direction of the current. And so now you have a look at your thumb. Which way is your thumb pointing? It's pointing to the left. So by swapping the poles over, we've changed the direction of the force, or the direction of motion of the conductor. Okay, so this isn't the only area where you'll come across the left-hand rule. You'll remember that we also use it when we're deciding how alpha or beta particles will be deflected as they pass through a magnetic field. So you might like to go on to have a look at that particular lesson in the unit on radioactivity.